Curtis,
Hello.
can you hear us?
Yes, can you hear me?
Yes, beautiful. I'll give you the
Okay.
stage.
Great. All right. Yes. Hello from the US West Coast. Good morning. And thanks for the invitation from the Flower team to talk about this project. We are working with NIST. I'm from the Census Bureau, as you mentioned, and we are developing metrics for privacy preserving federated learning. So today I'll give an overview of this project, what the origins of it are, and then a quick overview of genomic data, which we're using in this project. I'll also talk about the architecture and then challenge each of you to join a privacy red teaming project that we just started as well. So let's go over the outline. First, I want to talk about some of the project partners we have here. So NIST stands for the National Institutes of Standards and Technology. They have two programs that are spearheading this project, the Privacy Engineering Program and their National Center of Cybersecurity Excellence, or NCCOE. We're also working with two contracting firms, MITRE and Nexus, that are providing some engineering and data science expertise. And then I'm with a small team at the Census Bureau called XD. Our goal is to test new and emerging technologies like PETs to see how well we can use them to improve government services. So we know that sharing medical data is difficult between institutions and nations, but interagency collaboration is important for advancing medical research. And so we wondered if we could use PPFL to enable easier collaboration. And what we want to do is make that system more robust and verify how well it protects privacy. And so that's where the validation part of this project comes in. So what data are we using? Well, as I mentioned, we're using genomic data. And if you're new to genomics like I was at the start of this project, it's essentially the entire code base of an organism. And the genes contained in the genome influence the way that the organism functions and what qualities it has. So the origin of this project came from this paper. The original goal of the paper itself was to test different forms of machine learning models to see how well they would predict different qualities of an organism based on the genomic data. So in this case, the project used soybean plants. And that was a great way to start for us because nobody cares too deeply about the privacy of soybeans. And the format of the data looks like this. So in this table, each column is a specific soybean plant, and each row is an accession. So that's a specific location within the genome, and in each cell of the rows, each pair are contributions of the nucleotides from each parent. So you can see, for the most part, they tend to be the same, but there are some exceptions like this one in the lower left. And then the value here is the quality that we're predicting. So in this case, it's a continuous variable for the amount of seed oil that gets expressed from the seeds of that plant. But it could also be something categorical, like the color of the flower, for example. So a quick overview of the architecture for this project. We're using PyTorch. We're starting right now with convolutional neural networks for the predictions of the genome qualities. For privacy, we're using Opacus, which allows us to perform differentially private stochastic gradient descent on these CNNs. And then we're here at the Flower conference, so Flower was our federated learning framework of choice. And for getting into the privacy a little bit more deeply, we're comparing between three regular models as part of this experiment. So we have regular CNNs and then two forms of private CNNs with high privacy, low privacy, with privacy budgets of 10 and 200 respectively. So we really want to get like a wide range of how much the privacy can or can't be protected for these soybeans plants. And the architecture itself is not too complicated. We're kind of starting right now with 4 different clients. We have a threat model that assumes that the central model might try and reproduce some of the qualities of the plants that were trained on in each client. And for the future goals of this project, like I said, we've started off with plant genomic data. That proof of concept is done. I think the next step we're moving towards is animal cancer data with the eventual goal of using pediatric cancer data, and specifically rare pediatric cancers. Federated learning would be a great solution to this because by the nature of that data, you have very small populations of those patients. So imagine if we could build a system that could help the outcomes of these patients. If we had something like this, maybe at the start of the COVID pandemic, when patients in different countries were getting inundated in large cities first before it spread to the rest of the country, we could have saved a lot of lives and put aside all of the concerns that had to do with protecting patient privacy for rules like HIPAA in the United States. We could have just sent the model to the different hospitals and healthcare institutions and helped them better predict what the other hospitals could expect down the line from those patients. So looking to the future, we want to be able to do this for rare pediatric cancers and help protect the privacy of the kids and their families in the process of this research. So the next thing I want to do is invite you to join our red teaming exercise that we're calling Don't Spill the Beans and help us break the privacy of these soybeans. So we've just launched this project this month. We're continuing through the rest of April, and then we'll have phase 2 testing in May or June, so it's not too late to sign up. If you're at all curious about privacy attacks and genomic data science, we welcome all experience levels. You don't have to be an expert in any of these fields. The website has a few resource links, and our webinar launch video has more information. We also have a leaderboard for different contributions, so it's really up to you how much time you want to spend. And even if we get just a few dozen engineers and data scientists, and hopefully many more contributing to an afternoon or a couple of days or weeks, I think we'll make a big difference. And if we could build this more robust healthcare PPFL system, I think the possibilities are endless in how much of an impact we can make in medical research. So I want to do a quick acknowledgement. Some of my teammates, especially the team lead, Gary Howarth, and our technical lead, Christine Task. And now I'll open it up to questions.
All right, do we have questions in the room? I actually had a question myself. You talked about the next steps and some animal trials. What are the main roadblocks there? Is it more logistics or technical?
Yeah, mainly logistics. We've had trouble finding a good data set that includes cancer data. I think what we're going to end up doing is it looks like we're moving towards dog data. So we have a large data set of like healthy dog genomes, and we're going to pair that with a data set of cancerous dog genomes.
Got it. Thank you. Mm-hmm. Do we have any other questions? All right, then. Thank you, Curtis, for the great talk again. Oh, sorry.
Just one quick question.
Sure.
For the attack challenge, like for the red teaming, what's the size of the model that you are training?
Good question. I don't know the exact size of the model. And I think it might change. Well, because there'll be a couple different phases, it'll change according to which phase of the red teaming exercise you participate in. So the soybean one, I think, will be smaller than the animal genome one that will start in May and June.
Thank you.
Mm-hmm.
All right. Any other quick questions? All right. Perfect. Thank you, Curtis. All right.